Hello, classmates. Diodes are the core components of rectifier circuit. We have already understood its characteristics. To use a diode, we must learn the identification and detection methods of diodes. This section is about the identification and the detection of diodes. The goal of this section is to be able to identify the leads of a diode and to detect it, and to be able to select the appropriate diode in a circuit. Methods for identifying the positive and the negative leads of a diode by appearance. A diode has two leads in total. Two leads have positive and negative poles. In use, the two leads must not be reversed, otherwise it will damage the diode or damage other components in the circuit. The appearance of the diode and the identification of the positive and negative poles are shown in the figure. Usually, there will be a mark on the casing of the diode. Generally speaking, for ordinary diodes, the end with the colored mark is the negative pole. For light-emitting diodes, the longer lead is the positive pole, and the shorter lead is the negative pole. How do we detect a diode? We need to use a multimeter. A Type 500 multimeter is a commonly used instrument that can be used to detect AC and DC voltage, DC current, resistance, and to check for circuit faults, etc. When detecting a diode, we need to use the ohm-meter range of the multimeter. So, let's look at the method of measuring resistance with a Type 500 multimeter. Place the multimeter horizontally. Turn the left switch to the ohm position and the right switch to the appropriate range on the ohm meter. For example, select the 1K range. First, short-circuit the two probes and perform an ohm zero calibration. Adjust the ohm zero knob so that the pointer accurately indicates on the first scale line, where the right value is 0. Then, proceed with the measurement and read the value. The method for measuring resistance when using a 1K range is the measured value equals indicated value times 1K, and so on. It is important to note that after changing the ohm range each time, remember to perform an ohm zero calibration first. Then measure the resistance value. Now, let's learn how to use a multimeter to roughly test the polarity and quality of a diode. Usually, the ohm meter range of R times 100 or R times 1K is used to test small power diodes. When the multimeter is in the ohm meter range for testing, the red probe is connected to the negative terminal of the internal battery, and the black probe is connected to the positive terminal. When testing, first select R times 100 or R times 1K. Let's take the 1K ohm range as an example. After zero calibration, Use the two probes to touch the two leads of the diode. And read the value on the meter. Exchange the two probes and measure again. Noting down the resistance value. If the two resistance values measured are different, one large and one small, it indicates that the diode is good. Due to the nonlinear characteristic of the diode's volt-ampere characteristic, the resistance values measured with different ohm ranges or multimeters with different sensitivities will vary. The smaller resistance value measured is when the black probe is connected to the positive lead of the diode, and the red probe is connected to the negative lead. At this time, the measured value is the forward resistance when the diode is forward biased and conducting, which is about a few thousand ohms or less. The larger resistance value measured is when the black probe is connected to the negative lead of the diode, and the red probe is connected to the positive lead. At this time, the measured value is the reverse resistance when the diode is reverse biased and cut off, which is about several hundred thousand ohms or more. Please think about it, classmates. If both resistance values measured are very high, or if both resistance values measured are very low, what does it indicate? If both resistance values measured are very high, it indicates that the diode is open-circuited. If both resistance values measured are very low, it means that there is an internal short circuit in the diode. If the forward and reverse resistance values measured are not significantly different, it suggests that the diode has poor performance or has failed. If any of the above three cases, the diode should no longer be used. What we have just discussed is the detection of small power diodes. If detecting medium or high power diodes, the R times 1 or R times 10 ranges of the multimeter are generally selected. If detecting light-emitting diodes, the operation can be similar to that for detecting ordinary diodes, using the multimeter to determine the quality and polarity of the LED. However, it is necessary to use the R times 10K range because the forward voltage drop of an LED is generally greater than 1.5 volt, and all resistance ranges of the multimeter below R times 1K, including R times 1K itself, are powered by the internal 1.5 volt battery. When measuring the forward resistance of an LED, the value is generally less than 50 kilo ohm. At the same time, there will be a bright spot in the LED. The reverse resistance is generally greater than 200 kilo ohm, and there will be no bright spot in the LED. During the detection, If a small difference is found between the forward and reverse resistance values, it suggests that the LED may have weak light emission or may not light up at all. If both measurements yield very low or very high resistance values, it indicates that the LED is damaged. There are many types of diodes with different parameters. How do we select the appropriate diode for use in a circuit? First, choose the type of diode according to its use. For example, for detection purposes, a point contact type ordinary diode can be selected. For rectification, a surface barrier type or rectifier diode can be chosen. If used in high-frequency rectification circuits, a high-frequency rectifier diode is required. Additionally, for photoelectric conversion, a photodiode should be selected. For switching circuits, switching diodes should be used, etc. Second, after the type is determined, select the component according to the parameters. For rectifier diodes used in power supply circuits, two main parameters should be considered: the maximum rectification current and the maximum reverse working voltage. When selecting, it is necessary to leave a certain margin depending on the circuit conditions. Third, choose between silicon and germanium diodes according to the following principles. If a lower forward voltage drop is required, select a germanium diode. If a lower reverse current is required, select a silicon diode. The reverse current of a silicon diode is less than 1 microampere, while that of a germanium diode is about several hundred microamperes. Choose a silicon diode if a higher reverse voltage and higher temperature resistance are needed. The junction temperature of a silicon diode is about 150 degrees Celsius, while that of a germanium diode is about 80 degrees Celsius. Fourth, for diodes with a larger working current, reaching 1 ampere or more, it is necessary to install a heat sink according to the product manual. The current, voltage, and environmental temperature during the operation of the diode should not exceed the limit values specified in the product manual. In actual use, it should be noted that silicon and germanium diodes should not be used interchangeably. Diodes of the same type can be used as substitutes. If they meet certain conditions for rectifier diodes, as long as the reverse voltage withstand and forward current are higher than those of the original diodes, they can be used as substitutes. Good, classmates. That concludes our lesson for today. Goodbye, classmates.